Hi all, basically I want to show you how to solve a more complicated example of a trig function. And basically the reason that we want to do this is because, for example, in the last question, when we have equations like this, which have several transformations, if we want to find out the x-intercepts, then what we have to do is basically solve for when y equals 0, and we get kind of an equation that looks like this. And so it's good to just know how to sort of solve that, and I thought it'd be worthwhile going through it. So essentially, this is the same question. What we do first is we want to rearrange this in terms of the cosine. In this case, if it was sine, we would do it in terms of that. But basically the idea is that we want to have it as cosine, sine, whatever trig function equals to the number, because that allows us to solve for it. And in this case, we get from minus pi again, so to pi. And this is for x. The thing is, we can't solve for x right away. What we do know, what we have here is essentially we have cosine with something inside here equals to root 3 on 2. And so what we can do is basically we can solve for this thing here. And then after that we can rearrange for x. And so what we're going to do is we're going to solve for 2x minus pi on 3 first, if you like. And because we're solving for this, we then have to rearrange this domain. We can't have it in terms of x, we need it in terms of 2x minus pi on 3. And so we're just going to basically do a bit of balancing equations. So if x is from minus pi to pi, then that means that x minus pi on 3 is from 2 pi on 3 to minus 4 pi on 3. And then 2x minus pi on 3 is then going to be from 4 pi on 3 here and minus 8 pi on 3 here. And so this is the domain that we're basically going to solve for here. And later on we'll make the adjustments. And so as before, we're going to draw a unit circle, because that's helpful for visualizing this thing. And one thing to keep in mind is now in this case we're looking at cosine. So cosine is the x value of our unit circle. And because we want to know when this equals to root 3 on 2, basically we're going to look for all our solutions when the x value of the unit circle is equal to root 3 on 2, which is going to be at this point here and that point there. And basically using symmetry, we can just draw the lines across like before. And we know that basically this angle here is the same as all these angles here. And this angle, which I'll call alpha, that through our exact values, if we have cosine and we know it's root 3 on 2, through your table, or if you've memorized it, that's basically going to be pi on 6. And so now what we'll do is we'll start to solve this. Now, what I like to do with this is actually, when we have a negative value here, and we also have a positive value, I like to split these into sort of two halves. So in my head, you don't actually have to do this, but I'll write it out for the sake of it. But basically, I like to have a negative section, and then I like to have a positive section here. And the reason I like to do that is because the negative implies that it's moving clockwise, so we can then focus basically from going from 0 to clockwise. In this case we have 8 pi and 3, which is 1 revolution plus an extra 2 pi and 3. So we just focus on that negative section first. Once we found all our solutions, then we can move on to the positive section, which is basically going to be from 0, and we're going anti-clockwise because it's positive, and we're going to 4 pi and 3, which will take us about here. And so that allows us to basically split it into two parts. We don't have to worry about two things at once, if you like. And I'm just going to basically, I'm not going to do this in ascending order, I'm just going to pick whatever solutions come first when we do this. But let's have a go with it. Basically, if we solve for this thing here, let's do the negative part first. So we're going to go down, like I said, so minus 8 pi and 3 goes basically to around here. And so we should see that there's going to be a few solutions there. The first solution is going to be here, so that's going to be minus pi on 6. And so just keep in mind again that this is not in order, I'm just picking whatever I see first. And then the second solution, that's going to be, was it minus 2 pi plus pi and 6. And so I'm just going to save a bit of time there, that's minus 11 pi and 6 there. This one here, that's going to be minus 2 pi minus pi and 6, and saving a bit of time there again, just so we don't have to do a lot of rearrangement, that's minus 13 pi and 6. And then basically that would have taken us all the way to our domain, there's no other solutions here. And so those are our three solutions in the negative section. And then we have one solution here that's going to be in the positive section. When we take a look at this, so from 0 to 4 pi on 3, that's basically from here to there. So it's just that one solution here, which is at pi on 6. Like that. Okay. And maybe what I'll do now is I'll just adjust these from lowest to highest. Don't really need to, but it's for the sake of it, just convention. See that? And then now what I'll do is I'll solve for x. And so we're going to basically divide by 2 for each of our solutions here, and find x minus pi on 3. That's going to give me minus 13 pi on 12 here, minus 11 pi on 12 here, minus pi on 12, and pi on 12. And then one thing, because we're going to be basically, I'm going to be adding pi on 3 to each of my solutions, basically balancing equations. I'm going to be dealing with fractions, so it's just nice to change this. So keep in mind that pi on 3 is the same as 4 pi on 12. Like so. So I'm not actually changing anything, I'm just doing it so that the denominators are nicer. So that when I adjust this, I'm going to add 4 pi to each of my solutions, 4 pi and 12 to each of my solutions. Then that's just going to give me, what's that, minus 9 pi on 12, minus 7 pi on 12, 3 pi on 12, and 5 pi on 12. Okay. And then I might as well just simplify a bit further. That's going to be basically, what's that, minus, what's that, 3 pi on 4, minus 7 pi on 12, pi on 4, and 5 pi on 12. And so those are actually our solutions. Those are all the ones for x within that domain. And so if we wanted to connect this, basically that's how we'd solve it, and that's pretty much the question done. But just to link it back, so if we wanted to go into this graph here, what that tells us essentially is that we can then label this graph. So these intercepts here, that's going to be, what's that first one here? That's minus 3 pi on 4, 0, minus 7 pi on 12, 0, pi on 4, 0, and then was it 5 pi on 12, 0. And so that's basically the approach that you would use to find the x-intercepts. So you'd solve this sort of equation. So it is a bit messy, but that's how you do it. Let me know if you have any questions. Otherwise, I hope you enjoy the rest of your day.